Hello everyone. So today we are going to discuss about machine learning. What type of machine learnings we have? So machine learning is very important nowadays and becomes very important part in day-to-day life. So we have seen and you might have using uh, Apple Siri, Android, Google Assistant. So these type of robots we are using. Robots is not only about the physical appearance, it can be an anything machine that is can respond, we call it robots. So in India we are finding many type of robots being developed day by day. And as you can see in the picture, this is a new robot. And or in you can say in India the first lip sync robot. It can read your lips, and accordingly it can uh, it can reply whatever you speak. And this is the first robot, name is Rashmi. This robot can speak Hindi language in different accent. Like if I go in Uttar Pradesh, or if I go in Bihar, West Bengal, or Gujarat. So many people they speaks Hindi language, but dialect is different. The way they pronounce it is different. So this robot is able to recognize the dialect, and in their dialect it can respond. This was the advantage of this the robot. And second robot is very popular one, Vyomitra. Vyomitra robot. This robot we have sent in the Gaganyaan. Gaganyaan, it was launched in the 2022 by ISRO. And this Vyomitra robot was helping as a crew member. So anything like making a phone call, checking temperature, pressure, so all type of human assistant provided by Biomitra, developed by first humanoid robot sent in the robot. So still in the Gaganyaan, this robot is serving. So Gaganyaan was very successful mission by ISRO. So this is very popular. And here I would like to explain few more humanoids. Those are coming from different uh, part of India. Different companies has developed. But I want to tell you that till now, since 2024 February, the most advanced humanoid robot name is Skanda. SKA. It is this name is coming from Skanda Puran. And few robots are listed here. First one, Indro. The person name was Santosh Holavle from Maharashtra. The robot name is Indro. So this Indro was able to roam around your house, and it can talk. So these images can be found, or uh, can be found Indro robots. So this is the robot. Many videos are. So this is the robot Indro robot. So this robot is able to move around here and there. So this is the Indo robot. And we have a Corbo. This Corbo bot. This Corbo robot was introduced in during COVID period to as a disinfectant in the hospitals. Another one is Zafira robot. this robot was able to speak languages like Hindi language, English language, Marathi language, uh, uh, Bengali language, Bangla language, and Bhojpuri language. So many type of accent it was able to speak. Next one is Mitra robot. Mitra robot is developed by Indro Robotics from Bangalore. This robot was introduced in the Global Entrepreneurship uh, Summit. Modi ji has inaugurated this summit. Vyomitra, developed by ISRO, Bangalore. It was sent in the Gaganyaan. Rasmi robot, just now we have discussed, the scientist name was uh, Ranjit Srivastav from Ranchi. So that is why this robot was planned to speak in different accent: Hindi, English, Bhojpuri, and Marathi language. Whatever accent you start speaking, automatically it will respond in that language. Next one is Mitri robot. Mitri stands for friends. So this robot was able to perform tasks like as a receptionist, as a cleaner, as a security guard. So another robot is we have Manav 3D printed a robot named Manav. It was completely 3D printed by 3D printer, and it was able to control according to your human brain waves. Whatever you think, based upon the waves, it can recognize and it can respond. Next one, we have Campa robots. Campa robot is developed by Srina Technology, Bangalore. Robocop. It was able to recognize audio, video, metal, temperature, and sensing. So, especially this robot was designed to identify that objects, and based upon the objects, we can grab it. For example, if I say triangle or circle, so the way we capture it, grab it, the style of grabbing is different. So it knows what type of object it is, how much is weight, temperature, metal. If I'll give any human one piece of glass, then they will handle carefully. If I give a flower they will handle carefully. So this robot was able to find what type of object, how it should be handled. Next one is Radar robot. Radar robot is developed by Tata company. It This robot is serving since 2018 in airlines, Singapore Airlines. Another robot assistant we have HDFC Bank. They have developed. So this HDFC, in the HDFC Bank, they are using as a assistant. So if any questions do you have, immediately you can ask and it will respond in the proper, just like a human response. So it is able to speak, uh, it is able to respond in 8 Indian languages and 39 foreign languages, because HDFC Bank is operating in different countries as well. So that is the reason. Next, Bharti robot, the Bhilai Institute of Technology, they have developed, and during COVID period, it was helping to the doctors and staff nurses during COVID period. And next one we have Eagle 2.0 robot. It This robot can work just like a teacher, and this robot was developed by Indus International School Group and 17 team members. Robots can work as a teacher as well. So now question arises, how the machines are able to help us in the day-to-day life. How the machine can classify all these things. how machines are able to work just like a human. So it is nothing but machine learning is older than the machines actually. When we are not having a machine, that time we have algorithms how machines can be trained. So those algorithms we are going to discuss right now. So basically machine learning we have a three types, three category. First one, supervised learning, unsupervised learning, reinforcement learning. How machines can learn. So now if you see any programs, what is programs? Programs is nothing but just a way of instruction, and based on the instruction you are going to operate data. But in the machine learning we have just opposite of that. We are giving data, and based upon the data it will create a program by itself. Then this process is known as machine learning. So as you can see in the image, we are passing the old data, input past data, and machine learning algorithm we are applying, and a machine itself will develop logics, and finally it shows the output. Or you can say just like one small baby start learning. How it learns? It learns based upon their observations. It learns based upon the observations, right? So based upon the observation, it can start learning. Next, so this learning can be supervised, unsupervised, and reinforcement learning. In the supervised learning, we have a two category, classification and regression. Classification, I'm giving you two or three objects like a circle, triangle, or maybe red color ball, green color balls. So e- all are balls, but based on the color you can classify. Red color balls, in this box you have to keep it. Blue color balls, this in this box you have to keep it. So means based upon it's a feature, based upon the feature we are putting in the different boxes. So this is called classification. So what we did, already we have provided the label. Blue balls should be kept in this box. Red balls should be kept in this box. So means already we have defined the labels. So this type of learning, already we have defined the labels, we call it supervised learning. Classification. And another classification and example is regression. If you find continuous data, let's say I'm saying one student have salary 10,000 rupees, and how much he studied, how much he scored. So based upon the score and studied, based upon the study and scores, we can find new student, if they have scored this much, how much salary package can they grab in future. So the based upon the previous data we can predict the output. This data we are using in the banks as well. Like somebody is taken loan, so how we can know that one person will repay that loan or not. So this is a continuous data we consider inside the regression. Next one is unsupervised learning. Unsupervised learning, like I gave you balls, and I'm not telling you this is red color, you should put in this box, green color you should put in this box. I'm not saying that. I'm just saying you need to segregate. Just I'm telling you need to segregate. So based upon that you have need to figure out the features, and based upon the feature you need to classify, you need to cluster. Balls will come in this ball cluster, and uh, green balls will come another cluster. So clustering you can do. Next one is association. Association means those clusters are whatever clustering we have done, those clustering we have done, this clustering can be associated as per requirement. I'm saying green color balls, I want two green colors balls, four yellow color ball or different color balls, and I will create another group. So this is called association. Actually they are from different category or class or cluster, and we are joining as per requirement. As per requirement we call it association. Next one we have a reinforcement learning. Reinforcement learning is nothing but just like a computer learn by itself, by its observation, like a human baby when it is very small, and it try to touches fire, and parents are teaching, no, no, don't touch this, this could harm you. So but how baby can understand this? So baby should experience this. If baby will experience, so next time onwards it will not touch it. So same thing we do in the robot as well, or in the machines. Machines will do experience, they will make a mistake, punishment will be given. So this reinforcement is learning all about punishment and reward. If baby is doing good, the way we give a chocolate as a reward. If baby is not doing it good, then we can punish as well. So this type of things we can have. Next, supervised learning, same we have explained here. So we have a label data, we have a hexagon, triangle, rectangle, so different type of images we have. And now we are saying that this is a label data, and what are the labels? Hexagon should be one place, square should be in one place, and triangle should be at one place. So this is a this type of output I'm expecting. This is my raw data, and I'm giving to the machine model, and machine model can predict, and final output I will get. Square will go this side, triangle will go this side, hexagon go well another side. So this is how supervised learning works. So these are the some texts or theory, whatever I explained just now. So in the supervised learning, we need to determine the type of training data set, collect or the data, split data in two sections, uh, test data, training data, and validation data. Three sections we can define, and this data is defined based upon the sampling techniques. There are various type of sampling techniques. In the next sessions we'll discuss about sampling, how do we can do the samplings, and determine the new features like in this previous example, features is hexagon, square, triangle, these all, and determine the suitable algorithms. So here we are applying algorithms, which algorithm you should apply. In machine learning we usually says there is no perfect algorithm. Algorithm can be anything, and that may give us some accuracy, sometime may not be. So it is completely based upon the hit and trial, but I'll tell you the most of the cases which algorithms is working well. uh, Nowadays people are working on neural network inside the neural network, RNN, CNN. So these algorithm we'll discuss in the upcoming sessions. And finally, we need to execute the algorithm of the training data set. Sometimes we need validation data set as a control parameter, which are the subset of training data set. And finally, execute the accuracy model to test the accuracy of our model, how accurate our model is working. And we have a few algorithms in regression supervised training. If we find continuous data, each and every algorithm we'll discuss in the by hands-on. In this training, we are going to discuss 85 to 90% as a theory. uh, Hands-on means we'll write a code. I will be writing code, and 5 to 10 to 15% I will write theory part. So the theoretical part will be less and hands-on part will be more, because we cannot ignore theory. Theory also very important. So we have a regression supervised model, linear regression, regression tree, linear, non-linear regression, Bayesian tree, polynomial regressions, support vector regression, decision tree, random forest, ridge regression, lasso regression. And if we go in the classification supervised training, we have a random forest, decision tree, logistic regression, support vector machine. So how it works? Supervised training means one supervisor is trying to supervise you. So it means you have to explain the features first. But unsupervised learning, you need to extract feature by itself and then you can start training. So this is the difference between supervised and unsupervised training, as you can see in the picture. So what are the advantages of disadvantages of this? So with the help of the supervised training, supervised learning model can predict the output on the basis of prior experience. But disadvantages, supervised learning models are not suitable for handling the complex data. Easy data is okay, but complex data is not suitable. In supervised learning, we can have an exact idea about the classes of objects, and we have a supervised learning cannot predict the correct output if the test data is different from the training data set. And supervised learning helps us to solve the various real-time problems such as fraud detection, spam filtering, and so on. And the disadvantages, it is required a huge amount of data computation. In the supervised learning, we need enough knowledge about the classes. So supervised learning is not best. Unsupervised learning is good one. So next one, we have a supervised learning. Supervised learning, two category we have, clustering and association. As we have already discussed about it, clustering is a method of grouping the object into the cluster such that the objects with most similarities remains into a group and has less or no similarity with the group objects of another group. Cluster analysis finds the commonality, common features between the data and objects. So let's have a look on the picture. So input data set, we have a dog, cat, and we are applying some algorithm, machine learning algorithm. And after algorithm, we found that based upon their feature, finally we are able to segregate them. Dogs in dogs are in one cluster and cats are in another cluster. So how computer can understand all this? So this understanding is completely based upon their features. Next we have association rules. Association rules is an unsupervised learning method which is used to find the relationship between variables in the large data set. It determines the set of items that occurs together in the dataset. Association rules makes making strategy more effective. Like people is buying X item, suppose bread, and there's a chance that they will buy the jam as well. Like if if you are going to buy mobile phone, and there is a chance of that you are going to buy its cover as well. It's not mandatory, but there's a chance that you will buy a mobile cover. And if buyer is a woman, then woman type of cover we can suggest. If someone is a man, then we can suggest cover according to the man choice. So this is association rule we are using in the industry for suggestions. So like you have noticed when you visit Amazon, Flipkart, or any other website, so by default they are suggesting something, and this is according to your taste. And if you go in the YouTube, whatever type of videos you likes, according to your choice, YouTube is start suggesting videos. So we have some unsupervised algorithms like k-mean clustering, KNN, hierarchical clustering, anomaly detection, neural networks, principal component analysis, in independent component analysis, a priori algorithm, singular value decomposition. So these algorithms we have discussed in detail in my book. I'm an author, so you can search my name on the Google or any platform, Google or Bing or any platform. You can ask, this is me. I have written 5 different books. This is machine algorithm, machine learning using Python, and this is my another book, mobile application development using Python. So Python, I'm learning my basic. I'm considering as a basic language, and we are implementing. You can know about me on the Google Scholar. I have a 40 plus research papers, and this is my citation index. This is my citation index and research paper you can find. I am working as a professor in this university, Bluegrass, Liberia. So, and these are few videos available on YouTube. You can search my videos on YouTube as well. These all my videos in Python you can search. And this is for JUnit, and this is for Python basics. And I am part. So many features are available. Many videos are available. You can find any one and you can be benefited. So on YouTube you can find YouTube. So you can search all the videos on Spring, JUnit, Java, Python. So many videos are there. After that, if you want to know about me from Google or Gemini, just so you can just ask about myself, complete information it will give you. So these all information you can find. And same thing on Chat GPT also you can ask Chat GPT. All right, so now let's proceed. And these Chat GPT and Gemini, these applications are based upon the generative AI. So in my courses, I'm teaching prompt engineering, and I'm teaching the how to develop your own generative AI models. So these are few algorithms, unsupervised algorithm. These all we have discussed in my book, and these books are available on the Amazon, Flipkart, or across the world. Especially my book is very popular in the Europe or Germany. My book is published from Germany. The publisher name is D. Grutter. So now coming back to the advantage and disadvantage of supervised learning. Supervised learning is used for more complex data as compared to the supervised learning. Supervised learning is preferable as it is gets easy, get unlabeled data in comparison to the labeled data. Unsupervised learning is interestingly more difficult than the supervised learning as it do not correspond to the output. The result of the unsupervised learning algorithm might be less accurate as the input data is not labeled. So accuracy sometimes may be less. So that is why we have a different type of algorithms to improve the accuracy, and we have a XGBoost and all we'll discuss in the upcoming sessions. So what you require to learn as a machine learning engineer? So you require basic fundamental knowledge of linear algebra. Linear algebra is important. Basic understanding of statistics and any language or computer language. So Python language is very popular in the data scientists. So knowledge of calculus, especially derivatives or single variables, multivariate functions. So this is very important. The steps to start, how we can start the machine learning. First we need to collect the data, and then we need to prepare our data because many type of problems because your data may not be accurate. So that is why we need to prepare our data wrangling, like changing values, duplicate data, invalid data, noise reduction. So this is a part of sanitization of data. First, we need to sanitize our data, then only we can proceed. Next, we start the machine learning algorithm. It analyzes the data, selection of analytical technique, building a model, review the results, and finally training the model, test, and final deployment. So these are the steps we follow in all type of machine learning uh, projects. So how we can start this machine learning? First, we need to install Python on our system. So Python is freely available interpreter on online. You can go to website python.org and you can download the Python. And this is just like other softwares. You just select download and click next. Python is available on the platform Play Store as well, Microsoft Store, and you can install from here. If you are using Linux, same concept is available in the Linux as well. You can search Python. So any version of Python you can install. In my case, I am using this one. If you are using Linux, so I have installed Linux in my system. So this is Ubuntu as a operating system. So as a subsystem, Linux I can install, and the command is simple sudo apt install Python. So obviously I have a by default install, so no need to install in my system. I already have Python. So Python 3. So it's already I have. So you can quit from this. So sudo apt install python 3. So like this you can install. Already I have this, that's fine. And once you install this, then we need one any builder tool. Builder tool you can have by Anaconda, virtual environment, Jupyter Notebook, Spider. Anyone you can download. So usually I prefer the virtual env, and some people uses Anaconda. Anaconda you can download. So this is a website. I can go on the Anaconda. I can download and I can install. This is a builder tool. Okay. And next we need one text editor, any text editor you can use, like a notepad, IDLE is by default coming. This is IDLE by default is coming with Python, so here also we can use, but in my case I'm always preferring PyCharm, but same code you can try with other as well. And we can have a many type of data, like we can have a CSV data, we can create a CSV files. Many people they use a Visual Studio Code. So this is my Visual Studio Code, and people can create a CSV file, or CSV file is used for training purpose, unsupervised learning. So basically data can be type of numerical data, uh, you can say type of numbers, a categorical data like a yes and no, countries, ordinal data like a similar category that can be measured on basis of comparisons. So type of data sets, we have a data sets like images, uh, and these images can be downloaded. We have online many repositories available like ImageNet, Cypher, or Minist. So these online repositories, you can download thousands type of data sets available free of cost. You can use. So we will use them. Next, we have a time series database is available like a sensor data, medical data. In my research paper, we are using this time series data. Text data set like IDM, IMDb data, film review, and data set can be find from the different SQL server as well, SQL, NoSQL, Excel files as well. It is completely depend on the industry. In the industry, what type of applications your industry is having using. So let's see one program, small program, how to read one file, a CSV file, and print data. So we have a CSV file like this. This file we can write on the notepad, or CSV file you can be downloaded. So how the CSV file looks like, I'll show you. Plenty CSV files are available online. CSV file download. So many data sets, free data sets are available. They can be downloaded. So this is my CSV file. Any customer data, this is a data set. So you can download and you can see. In the CSV file, we have a 100 records. So this CSV file is downloaded. So this is my CSV file, and CSV file how it looks like. So this CSV file can be opened in the notepad as well. So on the notepad, it looks like this. And same file can be opened with Excel. So like this, I can open with Visual Studio Code. So in the Visual Studio Code, it's looking a little different. So view may be changed. And if you want to see this in the Microsoft Excel, we have LibreOffice. We can open this in LibreOffice as well. So the data is completely categorical format. And this type of data we can read in our require. So this is a Python code. You can read a CSV file. This is your file name, and we can read all the data. Dataset.iAllocation from first to last. All values I want to read. This is for x-axis. And the last one is y-axis, means whether the person will purchase or not. Means the last column we are considering as prediction value. So we want to make prediction. So this files can be downloaded for cleaning our data. We can download from this is a URL. So files can be downloaded. So this is another file, pandas. Pandas is a sanitation library. So this file I will share with you how to do the how to sanitize our file. Next, we have a linear regression. This is a very common or very basic, and you can say this is the ABC of machine learning. So always we start learning machine learning with from linear regression. Linear regression is nothing but simple formula y equal to mx plus c. So this is known as slope. What is the trend is following? So you can see the green dots, they are following one trend. Then this is the midline. So this midline, all these green points are around the line. So whenever next salary or experience will come, it will follow that. Here y, or you can say target variable, is dependent or x is independent. So this x is independent, y is dependent variable. So this type of all algorithm we'll discuss in this training. So it is used to analyze the trend and sales estimation, sales salary forecasting, real estate prediction, arriving to ETA's traffic. We uses few libraries here, and the very popular library in machine learning, we have a fit intercept, is we have normalize, xcopy, njobs. This machine learning library sklearn, or you can say scikit-learn, scikit-learn, scikit-learn is very popular for models, or all type of algorithms are available in this library. Just you need to call that library and all algorithms in your system. So we will discuss about this in later in the uh, upcoming sessions. So some examples we have here: NumPy we have imported, and linear regression I'm trying to implement. NumPy sklearn. Sklearn is a, as I discussed, sklearn is very powerful library for machine learning. So linear regression model I'm calling here, and this is the data, x data we have and y data we have something, and we are trying to calculate the coefficient, intercept and slope, and finally you will see the output based upon the formula of y equal to mx plus c. So this is what the output you will see. This code, I will share the slides with you, and these slides, uh, this code you can copy paste and you can execute. But I will recommend read each and every line, line by line, and then execute the code. Do not make hurry burry. Learning is very important, and go slow, then you can learn better. So these all code I have mentioned as examples with snapshots. So that is why I explained in my training I am going to provide 85 to 90% as hands-on. And if you see my study material as well, they are based upon 85 to 90% hands-on and practicals. Okay, so these all code you can try multiple linear regression. In this we have, in simple linear regression we have only single line, but in this we can have more than one prediction as well. So this is called multilinear regression model, and we can calculate the accuracy and coefficient. See, this is logistic regression, is a sigmoid function. So this is a formula of sigmoid function, 1 upon 1 plus e power x. So sigmoid function is always giving you output between 0 to 1. So it represents just like a English character S. So logistic regression function output is always 0 and 1. And E stands for Bayes natural algorithm. And this also, another one is polynomial, means all dots. Polynomial is more accurate in comparing to linear regression because we actually follow the correct trend. It is more accurate and precise information you can find in this polynomial. In the polynomial regression, the main important features are degree, intersection, and include bias. So degree is an integer that represents the degree of polynomial regression function, and the Boolean false decides whether include only interaction features or all features. It includes bias. By default, bias is true and it can be changed. So this is a few code is given to calculate binomial polynomial regression features, along with the complete examples. You can execute by yourself. And support vector machine, yes, support vector machine we are using in the linear regression, in the regression, as well as in the neural network, CNN, RNN. So means this is widely used in different algorithms. Support vector machine regression is a regression algorithm which works for continuous level data. So these are hyperplanes. These functions. Kernel is a function is used to map lower dimension data into higher dimension data. Hyperplanes is a support vector machine. It's a separation line between two classes, but in the support vector regression, these lines help to predict the continuous variable and cover most of the data points. Next, boundary lines. Boundary lines, these boundary lines, if something goes out of these boundary lines, we consider as outliers. Outliers are always gives a hard time to make prediction, and because of outliers it decrease the accuracy as well. So that is why it becomes very important to deal with outliers. This is very important. Okay, so we'll discuss about this technique as well, how to deal with outliers. Next and very important decision tree, like in day-to-day life we makes decisions, like I'm going to a restaurant, but do do I'm feeling hunger or not? So if I'm feeling hunger, then I'll go to restaurant. If I'm not feeling hunger, I will not go to restaurant. If I'm going to restaurant, then I'll check, do I have a money in my pocket or not? If yes, then I'll go to restaurant. And do I will get that particular dish what I want, I'm looking for? If yes, then I'll go to restaurant. Do I will get the place to sit there? If yes, then I'll go to restaurant. So like this in day-to-day life, we makes many type of decisions. So decisions, similar type of decisions made by the machines as well in the decision tree algorithm. So as you can see, age is over 25, then married, or no, then sports car can be buy. So if married, yes, then luxury car or sport car. So that can be decided. And next one is very popular and more accurate, more precise data handled by random forest. Random forest, multiple trees, they will come together and they will do their prediction, and final predictions or average prediction is called, can be done with the help of random forest. Basically this algorithm is very popular to reduce the overfitting problem. Overfitting problem means whenever we are training our model, testing our model, so training and testing it is performing well was, but when we start in the production it not work well. So this problem is known as overfitting. Next we have a regression, the robust version of linear regression. We call it ridge regression, which is small amount of bias is introduced so that we can get better long-term predictions. The amount of bias added to the model known as ridge regression, or you can say penalty. We can compute this penalty term by multiplying with lambda or squared weight. Squared weight. This is a formula. Uh, so formula is given on the top. Minimum length limit, minimum limit I equal to 1, or maximum limit is n. So that is why we said algebra is very important. Next we have a lasso regression. Lasso regression is another regression technique to reduce the complexity of our model, and it increase the accuracy of our model. It is similar to the regression, except the penalty term. Penalty term is not available in this. Only absolute weight is there. And because of absolute weight, it is always performing well. It is giving a more accuracy. Since it takes absolute value, since it shrink the slope 0, whereas ridge regression can only shrink near to 0. It is called L1 regularization. Next one is cost function. Cost function is always used to know the how much we lost. So this will help you to calculate the accuracy of our model, and we always call it mean squared error. So to evaluate our accuracy of our model, mean square error, the formula is if MSE equal to 1 by divided by n, upper limit and lower limit. So this is the difference, the weight or coefficient of lines 0, A0, A1, gives the difference lines regression, and the cost function is used to estimate the value of the coefficient for the best fit line. Cost function is optimized the regression coefficient or weight. It measures the how a linear regression model performing. And next one is optimization function. Means our model is performing well. Our model is performing well, but can we improve the performance? Yes, gradient descent will help us to improve the performance of our application or our model. So this is always helping us to minimize the or calculating the cost of the function. The regression model is uses the gradients descent to update the coefficient of the line by reducing the cost. So this is a formula to perform the optimization. We call it R squared. R squared is a statistical function that determines the goodness of fit. It measures the strength of the relationship between the dependent and independent variable on the scale 0 to 100. If your model accuracy is 90%, it is good. If it is more than that, it is best. If you are getting accuracy is around 50%, then your model is not acceptable at all. If you are getting accuracy more than 50, then it optimization or improvement can be done. Now next term we uses in the industry, we call it backward elimination. In this feature selection technique, while building a machine learning model, it is used to remove the features that do not have a significant effect. For example, if something feature is not relevant, then we can eliminate that. So some of the light all-in-one back elimination, forward selection, bidirectional elimination, and score comparison. Back elimination steps are: firstly, we need to select the significance level of the stay model SL equal to 0.05, and it fit the complete model with the possible predictor independent variable. Uh, we calculate this known as p-value, and again we predict and finally remove the predictor and rebuild our model in terms of improving the accuracy of model. So this is the code given here. You can execute and you can train according to your requirement. For backward elimination. And thank you for joining today.